how are we doing? Oh my goodness, it's time for another live. I can't believe it. I'm so excited today. A big shout out to everyone that's already in the chat. Please come say hi. Come say how you're feeling today. What are you up to? Is it the morning for you? Is it the nighttime? Are you taking a break from work? I'd love to know. Please come say hi in the chat. And we'll just start in another minute. I am currently just waiting for everyone to come in. It sounds like we have a few people that are still waiting for the live to load for them. But that is all good. I'm so excited though. We have Jerome saying hi everyone. Learning Buddy saying when will it start? Oh my goodness, it's starting now, Learning Buddy. Thank you so much for waiting. And we have Erwin saying hi Erwin saying back. We have Mariana saying hello. Mariana, I swear this is our third live in a row together. Thank you so much for being here. Syed saying hi everyone. Welcome back, Syed. Joe says it's a live? I thought it was a premiere. It is a live today, Joe. So I am very looking forward to you coming here for the vibes. It truly is just so much fun when you're here too, Joe. Thank you. Rowie says, good morning, everyone. Oh, it's a morning for you, Rowie. Where are you based? Where are you based? I'm guessing from time zone. Usually it's around morning in Africa right now. Are you kind of around there? Oh, it's also morning time, I think, for people in Europe and for people in the UK. We also have Syed saying it's afternoon here in India. Thank you so much, Syed, for spending your afternoon here. Life is full of surprises. I love you. Thank you so much for being here. You've been a huge support in all of our shorts. And we have
Hey
Maximus
guys,
over here.
I'm just pouring her some tea.
Thank you so much, Maximus. I'm sure all of you would have seen Maximus as well in some shape or form in the community or in social media. So it's his first appearance on a live like this, I think.
Have a great live, guys. I'll be tuning in on the YouTube comments. And I'll be checking in. But good luck with that.
Thank you so much, Maximus. He's been threatening me all day that he'll do something random on the console for me. But we'll see. Wish me luck, everyone. We also have Desiree. Hi, it's still your Desiree from Mali. Morning time 8 a.m. That's cool, Desiree. Yeah, it's also morning time for Mariana. And Roe's in Israel. Thanks so much, Rose. Thanks so much, Rowie. Tanvir is from India. Learning Buddy is also in India. It's 1 p.m. there. And yes, Syed says, hi, Maximus. We also have Joe saying, hello, stranger. Good to see you, Maximus. All right. Tanvir saying, this is my first time on live. Cool, Tanvir. Very cool. I hope you enjoy the vibes in this live. It's all about just hanging out in a room, doing an AWS project together. And honestly, these lives are also where we go through a project in a slower kind of style, where instead of just running through the steps, we're really here to talk about why are we doing this step? Can we try to understand the concepts behind it? Can we start a discussion about it? I hope you enjoy. It's truly for people who are wanting to really understand what's happening when you're doing something hands-on with AWS. And we have a bit of bands in the chat. Thank you so much, everyone. It is so nice to see the energy just so lively already at the very start of our hangout today. And I think this is just perfect, knowing that we have a pretty full-on project coming here today. It's containers on Elastic Beanstalk. So we're going to be learning two different concepts and learning them at the same time, or learning them at the same time in this project and combining them across 6 steps. So today we're going to learn how containers work first and foremost. Okay, we're going to be spending literally the first 5 steps just about containers and just about Docker. And then in the very last step, we'll be learning more about Elastic Beanstalk, and then we'll be combining our amazing work with Docker with Elastic Beanstalk. So I am very confident that this project is beginner friendly. This project is a great way to just get to know what containers are, what they mean, and we will be explaining every single concept as we go. Now, it is still like an easy-ish project. It's not really easy peasy because I I would say if this is your very first project of all time on AWS, this might be a bit much to learn. Containers at the end of the day are still slightly more complex to learn compared to some simpler projects or some simpler concepts. So if this is your very, very first project, please know some of the concepts might be a bit complex, but don't let that turn you away from AWS or cloud. Just know that there are simpler concepts that you can pick up first that's gonna make learning containers a little bit easier. All right, everyone. It is cool to now jump into the 30-second summary for today's project. So welcome to this compute project on containers and Elastic Beanstalk. So in this project, you'll get to create your own container in a very beginner-friendly way, I promise, and you'll run it using a platform called Docker. You'll also meet this awesome AWS service called AWS Elastic Beanstalk, which will help you deploy your containerized application in the cloud and make it available to the world. So why would you care about containers? Well, developers, when they're creating applications, they often use containers to package up their work and share it in a way that's really, really easy for other people to run. Using containers has been an absolute game changer for making software fast and efficient, and it's also the reason why deploying software is now a lot simpler. Okay, let's talk about this one more time. So why do we care about containers? It's because developers can use the power of containers to wrap up their applications, wrap up their software, wrap up their work in a way that's a lot easier for other people to run and get up to speed very, very quickly. Now, I've learned today from our dear head of engineering, Kaldas, and a big shout out to Kaldas in the chat as well for saying hi, for sharing with us that, containers are very, very important and very, very helpful in a work kind of setting. It is developers working in a team, people trying to share code with each other. That's when you'll be really using containers. The concept of saying I'm packaging up my work and sharing it in a way that's easy for other people to run, it's easy to read the sentence and assume that means I, as a creator, can package up my software so my users can run this software very easily. But it's not really what containers were made for. Making this application available to my users, making an application you develop easy for your users to run, that's probably more on the deployment side of creating your software. But what if you want to share your software while you're still in the process of creating it? Then that's when you're thinking, let me use containers so that we can share this application around or share our work around in a very, very efficient way. Of course, it's not just about you sharing your work, you sharing your code. It's also about you getting up to speed with other people's code and other people's work very, very quickly too. Imagine if you wanted to build something and actually someone else has already created the software that can speed up your own work. Imagine if you can just get everything that they've built and all of this hard work that they've done in a very, very easy to run package and just use their work and jumpstart what you're building very, very quickly too. That's also another great way that containers is being used right now. And absolutely, containers is just this kind of tool, this kind of technology that is so widely used that it is so well worth learning. And Docker is very, very popular as well as a containerization platform or as a container management tool to help you use containers in a very, very fast and efficient way too. Okay, so that's a bit of a summary, that's a bit of an intro to containers. We'll talk about Elastic Beanstalk too, but we'll just need to make sure that containers is kind of our main character in today's project, so that's why this intro is focused on containers. Thank you everyone in the chat for saying hi. Tanvir completed 7 projects through this channel, which are extremely helpful for me as a newcomer. Syed says, whenever I see you, Nat, I always think about how you're so happy always. What's the secret? Oh my goodness, Tanvir. That is extremely, extremely, extremely kind of you. And Kaldas thanks for saying me too. I just think being around such awesome people naturally makes me happy too. And I'm sure that resonates with everyone in the chat, everyone in the Nextwork team, absolutely. So a big shout out to everyone in the team, everyone in the community, everyone in this live right now, for being the reason why it's always just such a good time here. All right, so in this project, get ready to install and use Docker. That's the first thing we're gonna do. And then we're gonna use Docker to build a custom container image. And this is a bit of a two-step process. You're gonna see what I mean in a second. Run your containerized application locally. So this falls from this step here. So after you build that container image, you can run your containerized application. So when you build that custom image, you're pretty much packaging up your application into this image, so that when you use Docker to say, hey, here's my container image, can you now spin up a container? Docker will go, okay, sure. And it will read your container image, say, oh, okay, I see what kind of container you need. And it creates the container, and that contains your application inside. So now you can also deploy your containerized application to AWS Elastic Beanstalk at the very last part of this project. And once you deploy it, which by the way becomes a lot easier when an application is containerized, once it's deployed, you can access it live on the web. It becomes public to the world. Cool beans. So let's roll up our sleeves and do this in the next hour. If you have any questions at any time, please add them to the chat. That's what the chat's for. It's here for the bants, here for the vibes, here for the questions. And let's get started. So please choose whichever mode suits you best when you open this project step-by-step guide. Now, you can check out the link in the description box for this video to see where you can find this guide. Okay, you can find it straight away in the link in the description box. And we're going to be using high touch today because we want to talk about every single step in this project, okay? And if you're ever stuck and this live is finished and you're like, oh my god, I can't ask the chat anymore, that's when you can definitely ask the Nextweek community. Students like you are already asking questions about containers, already asking questions about Docker. So you can definitely come along, share your thoughts, and we can help each other out. Okay, if you've done a Nextweek project before, you'll know exactly what I'm about to say, but really, if you want documentation for your project, and that means if you want a PDF tailored to your work and all of the things that you've been doing for this project, that you can share in your resume, that you can post on LinkedIn, it's awesome. All you have to do is fill out some tasks, some questions that you'll see later in this project, and it will literally automatically generate for you. It really feels like magic. I'll show you how it looks as we do this project together. All right, so today, let's get started straight away by setting up an IAM user. So we're gonna do step 1 together, but before we start, it's just important to just know what you're about to do today. We're about to dive into a 1 hour long project, so let's make sure we kind of know what this hour is gonna be about. All right, I'm noticing that my text box is looking a little cute today. Look at these fonts, it's looking so big. So I think what I'm gonna do is I'm actually gonna make everything slightly smaller so it doesn't look so big here. Bear with me everyone, it's just gonna be another second of me trying to find where I can change the font size of my things, and then changing that for you guys. So let's get that done. Alright, so I hope it's not too small everyone when you see it like this. Is it too small? It might be. Let me know if it's too small everyone. I have a gut feeling that it's a bit small. So maybe I should change it back to something that's like in between. Let me just quickly change this up for everyone, so it's not looking too tiny. Alrighty. Gut feel still says it's a bit small. Please confirm in the chat for me if you'd like this to be slightly bigger. If it's already like good enough, you can see fine. In the meantime, I think I'm going to just make sure this isn't too small. All right. Oh dear, I think I made that too big. Oh, okay, cool. I have a feeling that the text isn't getting any bigger actually. but if it's okay, if it looks okay, I think I'll move on. Okay, I'll move on, everyone. Thanks for sharing that it's fine. So I'll continue on with the project. Again, if it's ever a little bit too small, let me know. All right. So as we get started, let's talk about what we're here to do today. And in this project, we're really here to first use. Oh, now it's too small. Someone says now it's too small. Okay, thank you so much for letting me know the font is now too small. And I am going to fix that up now. Earlier it was fine. Oh my gosh, it was literally fine. And now I've made it too small. So clearly there was something that happened that made it a little small. But that's okay. Everything is fixable. So all we gotta do is just say, hey, can we make the font size back to like what it was before, please? And thank you. I think it's back, everyone. We're back. I think we're back to the beautiful font size. So thank you so much for your patience. And now let's work on what we're here to do today. So in this project, we will first install Docker. We'll first install Docker and use it to create containers. And then we will create our custom container image. Last, we will deploy our containerized application to the cloud using Elastic Beanstalk. I think just like that, we've kind of set our intention for the day. And again, if you're like, oh my gosh, I don't know half the words here, what is Docker, what is containers, custom container image, and a containerized application, if it feels a bit new, that's totally okay. Just know that what we're here to do today is learn about how containers work and then how we can use the power of containers to deploy an application to the cloud in a very fast way. Cool. Alrighty. So we have people saying the font is looking good now. Thank you so much. And Benedict says, it's okay, everything is fixable. I think this is one of the secrets. Thank you so much, Benedict. Love the vibes. And it's good to have you here. Cool. So the very first step of any project using AWS is that we would love for you to sign in using your IAM user. So the IAM user, if you're not familiar, is basically kind of like this user account for your overall AWS account that's separate from like the root account. So when you first create your AWS account, it comes with a root account, and that's like your main kind of sign-in that you get by default. But just using your root account to do all your AWS projects actually exposes you a little bit in terms of your security settings, in terms of things like billing information, and really what you want to do is have a separate user account within your AWS main AWS account that lets you just play around with AWS in the day-to-day while still protecting your main account in the background. So we go through how to set up an IAM user multiple times, which is why I'm actually going to be skipping this step for this project. And if you're new to IAM users, all you have to do is follow the step-by-step guide that takes you through how to set one up in just less than 10 minutes. I would also recommend that you can check out the link in the description box that gives you a video demo on how to set up an IAM user. But really, once you set one up, you can just use it for all time as you keep your AWS account. You don't need to delete your IAM user. You can just keep using the same one. So really, it's like a set once, and you can just like use the same IAM user for a long time. So in this case, I've just logged into an IAM user that I've set up in the past. And the same for you too. You can definitely just log into an IAM user that you've set up before. And please make sure you do use that IAM user. And once you have logged in, you can move on to step 2 straight away. All right, so hello to everyone now in step 2. We're now talking about installing Docker. Okay, please make sure right now in front of you have your AWS console. Please log into your AWS console using your IAM user. But for now, we won't be going into the AWS console right away. We're actually going to be going out of the AWS console to get to know something else called Docker. So welcome to Docker. We're going to get to know this iconic tool. We're going to install it and then use it for the first time in this step. So in this step, we're going to install Docker Desktop. All right. I think this step actually you might do in the next step. So forgive me for letting that slip and letting it slip into this step's description, because really we're just going to be here to install Docker Desktop here. All right. So in this step, we're installing Docker Desktop. Period. Period. All right. Thank you so much, Michael Winton in the chat saying, hello, love your work, Nat. Thank you and the Nextwork team for these wonderful projects and streams. And thank you, Michael Winton, for the good vibes and the good energy every single time, Michael. It's always so cool to have you here. Really appreciate your support. It's just awesome. It's just awesome. All right. So in this set, we're just installing Docker Desktop, and let's jump straight into it. You can head over to the official Docker website using this link. All right, and you can select download Docker Desktop here. Boop. Whoa. Okay, so you head to this main Docker website, and there's gonna be a nice little button already ready for you saying download Docker Desktop. And that's where you get to pick which version of Docker Desktop you'd like to download. So in my case, I'll just be using download from Mac Apple Silicon, but you can definitely make sure to check which one is most compatible for you before you click your option. Now, if you're unsure which chip or which settings would suit you best, you can use this guide as well to find out. Awesome. We have Amber. Woo! Go Amber! Amber saying, go Nat, I love containers. Thank you so much, Amber. And you know what? I'm loving containers more and more too. I think containers is one of those things where the more you use it, the more you're like, oh, there's such a good reason for containers existing in this world. And I'm sure Kailas, our head of engineering at Nextwork, is a huge fan of containers too. Learning Buddy says, I have a student account. Do I need to do the IAM user step? I think it is absolutely best practice to be creating the IAM user, so yes, let's go ahead and do it. And if you run into any struggles with that, Learning Buddy, just know that you can ask the Nextwork community for help too. Okay, so the Apple Silicon option is the one that works best for me, so I'll be clicking on that and letting that download. Off it goes. Now, downloading Docker Desktop usually takes a few minutes. I don't know why it's going crazy fast for me today, but all right. I'm gonna try beat it by saying, let's go through one or two, I guess, definitions to get us started with this project, okay? What is Docker Desktop? You know, this thing that we're literally installing right now? Docker Desktop is a program that makes it easy to work with Docker. It's a tool for, Docker is a tool for creating and managing containers, which we're gonna talk about next. But in the meantime, just know that Docker Desktop is kind of like this interface that makes it easy for you to use Docker. Okay, so when you download Docker Desktop, this app, you're not really just installing Docker itself. You're kind of like installing this app that makes using Docker easy. But Docker Desktop does also come with a suite of other tools that includes, you know, Docker itself, Docker, this app, this interface, and a few other cool components about Docker that we're going to get to know very soon. And engineers will use Docker Desktop to build and test, deploy applications right from their computers, and just use Docker in a very user-friendly way. It's kind of like how, what is the AWS Management Console? Is it AWS itself, Not really. When you visit the AWS Management Console, you kind of like seeing this interface that makes using AWS very easy. You can now just use clicks. You can just type into the search bar to navigate all these different services that exist in the AWS ecosystem. But it's not exactly like this is the entire like AWS cloud computing like software itself. And you can think about Docker Desktop in the same way. It's this app, it's this program that makes using Docker, the tool, very, very easy. Cool. And this project is so good, says Amber. It's so hard to find a good project on Docker and containers. Super excited. And yes, Joe, it is the Amber Joseph. It is the Amber Joseph, founder and CEO of Nextwork. Woo! So it's very, very cool to have Amber in the chat too. All right. What are containers and why do they exist? So we've learned that Docker is a tool that helps us with creating and managing containers. Okay, Docker helps us with creating and managing containers. But what are containers themselves? Why do they exist? So containers exist to solve this common problem that comes when you're trying to run the same software on different kinds of computers, different kinds of servers, different kinds of environments. Think about how just now we had to pick this very specific version of Docker Desktop instead of having a single Docker Desktop app that anyone running any kind of operating system can just download and just run and just use on their local computers. The software that you develop is very, very similar. Software is not guaranteed to run and behave the way it's supposed to in all these different kinds of computers because each environment, well, really like each operating system, can have their own unique set of applications or software inside, and that really impacts the way that they run things. And to be very, very clear, containers help tackle this problem in two ways. So the first way is it helps you with packaging up your own applications. So once you're like, okay, I'm working on this very, very important piece of code, or I'm working on this application that I've had to install a lot of things for, that is also pulling in from all these kinds of dependencies, which are like external pieces of code that your application will rely on to work. Let's say you have a slightly like complex setup that you've kind of set up locally just to make sure your application will work. What's going to happen is if you're going to say, hey, to the person sitting next to you, let me show you this cool piece of work that I've been working on, and you just try to like drop your work into their computer and they try to run it, it's likely that because you don't have that complex setup you spent so much time building in your local computer that application, that software, doesn't run the way it's supposed to. Or in some cases, it just doesn't run at all. So when that kind of situation happens, you end up spending a lot of time just trying to get other people in your team up to speed with something that you've been building. Now, containers help you just package up that application in a very, very simple, easy to run file. So now other developers, other people in your team can just run that file, and it gets them up to speed a lot faster. I also want to clarify again that containers are mainly used in kind of like a developers working together kind of setting. I understand that the word users has popped up here, but to clarify, it's not really about a developer trying to make their application available to their users. It's kind of like about developers trying to work on applications together or trying to share software together in a very efficient way. Okay, so the second thing that it helps you with is, again, it helps you run other people's applications and software much faster, because now applications that you want to use, software that you want to use, can arrive in a way that lets you run containers. And then once you can run the application, as a container with a container, that means you can now just get it up and running, working on your computer much, much, much faster and in a much more efficient way than if you had to set up like virtual machines or set up EC2 instances just to get it going. All right, so we're gonna now just start to use Docker Desktop in a second, and you're thinking, okay, we've learned that Docker is a tool for managing and creating containers, And then we have Docker Desktop, which is kind of like this interface that makes interacting or using Docker more efficiently. And then we also have Containers, which is like this extremely powerful tool that's kind of like the foundation of this project as well. And containers are a way for us to package up our application in a way that makes it very easy for other people to run as well. Okay, so if you want another explanation on containers, you're more than welcome to check out this analogy of containers being compared to cargo on ships. But in the meantime, I think it truly is, nothing really beats just having a go at using Docker, having a go at using Docker Desktop, and then explaining how it's working in the background too. So let's jump to that, and then, let's write an explanation on containers first and foremost. Cool. So what are containers? Goodness me. Shall we do this? Let's do it together. All right. Containers are tools for packaging applications in a way easy for packaging applications in a way that's easy for developers to run. They are useful because it helps developers, engineers working in a team together to share their work in a more efficient way. Awesome. We'll click done. That's looking awesome. And then we will now get started with installing Docker Desktop itself. All right, so here we have Docker Desktop very kindly just opened up automatically for me. But really, if you can't find it, you can probably find it in the downloads folder in your local computer. So over here, this is downloads for me. And once you click on this, okay, that's when you'll get to this screen here. For example, for me, I get to just drag and drop it. And I think this is quite a good experience for Mac. But if you're using Windows, there are also other instructions for that too, as well as Linux. All right, so I'm exposed here because it's telling me that an item named Docker already exists in this location. You won't see this if this is your very first time installing Docker. I am, because I've been exposed as someone that actually already has Docker in their computer. But we'll just replace it so that I am showing you the true experience of moving Docker into your applications folder on your computer if you're using a Mac. I also really appreciate DevOps methodology for explaining that each container runs as an isolated process in a user space, and that takes less space than regular virtual machines due to their layered structure. Yeah, that's very true. I think as you learn more about almost the science behind containers, or the reason why containers really helps with making things more efficient for developers, you're going to start to learn some really interesting concepts, like containers running as an isolated process, things about how containers share a kernel with the host machine. All of that you'll get to learn as the concepts come. For now, I think what's really important, well, the key thing to know here is that containers exist to help developers share their work and also help you run applications in a much more fast and efficient way. Awesome. So let us go into our applications folder now that it's been moved in there. And I can see that it's right here for me. Okay, and you can also, if you're using a Mac, for example, you can also find it in your applications folder by clicking on Finder and then navigating there. Okay, awesome. So let us open Docker Desktop for the first time together. Pretty exciting. And this is where you might run into this little pop-up, this funny little pop-up that says, it's an app that's downloaded from the internet. Are you sure you want to open it? You can definitely click open in that for that pop-up. Okay, So welcome to Docker Desktop. It's looking beautiful. It's looking real fancy for me. And if this is your very, very first time looking at Docker Desktop as well, we're going to get to know some of the components on the left-hand side of the screen. And just as a heads up, if you end up seeing actually this other screen, I'm going to open it with my on the step-by-step guide here. If you end up seeing the sign-in pop-up, just know that you can skip the sign-in pop-up, and know that even if you skip without signing in, without creating an account, all of your work will save because you've downloaded Docker Desktop locally into your computer, so all of the local work that you're doing is going to work fine. It's only if you ever want to save your work in the cloud that you might want to sign in. But for now, we're actually going to be using Docker locally in our computer. We don't really need to save our work in the cloud, and I'm gonna show you how this is gonna work. Okay, so we're now looking at this Docker desktop dashboard, and this is where you can manage your containers. So these are the containers that you can start, stop, you can manage using Docker. And then these are images over here as well. So images is where you manage your container templates. We're going to talk a lot more about images in just a second. And volumes is where you can access data that you've saved in your containers, even if you stop or you restart a container. So people always say like, oh, volumes is where you manage data outside of the container. And that basically means data that's from the container that is now pulled to an environment, pulled to a space where you don't need to be inside the container anymore just to access that data. You can access the data outside of the container now. And builds is where you manage the images that you custom created or loaded into Docker. So again, we'll talk more about images here later on in the project, but builds is basically images that you've custom created for yourself. Docker Scout and extensions we don't really talk about in this project at this stage, but you can think about Docker Scout is great for analyzing anything for security issues. Extensions is where you can pull in some really cool software, really cool tools from other creators and use them together with Docker Desktop. Okay, so let's take a screenshot of this lovely Docker Desktop dashboard and let us go through. Oopsie daisies. I think there's a small little error with how I took that screenshot. So let's take that screenshot one more time. Cool. And drop that in. And now let's talk about what is Docker and what is Docker Desktop for this question. All right. So Docker is a platform for creating and managing containers. Docker makes working with containers easy. Docker Desktop is a software for using Docker, interacting with Docker. Docker Desktop makes working with Docker itself easy. Okay, so we have Docker, which is a tool that makes working with containers easy. And again, another level up, Docker Desktop is a tool that helps us with using, that makes using Docker itself easy too. So really, with the help of Docker Desktop, we get to a stage where we can control and manage our containers very, very easily because we are pretty much using Docker and this Docker tool with using clicks in the desktop, in the dashboard. Done. Awesome. So why would I need to verify if I've installed Docker? Because now we're going to make sure that we've actually downloaded Docker successfully. Please make sure that this is something that we're going to talk about soon. So please make sure to verify that you've installed Docker because we have to think about Docker and Docker Desktop as two different things. So like we've mentioned before, Docker is the tool for actually managing and creating containers, while Docker Desktop is just this app that makes using Docker more interactive and more efficient. So downloading Docker Desktop, just downloading this app and having this app open in front of you, doesn't necessarily mean you've actually downloaded the Docker tool itself. So it's very, very important that we actually just check, have we installed the Docker tool itself using the terminal, so that the rest of this project you won't be running into errors. Okay, cool. Awesome. We have King of Zamunda here. Hi, King of Zamunda. I always remember King of Zamunda as someone that jumps into the chat and says, Hola, hola everyone, hola Nat. Not too late, am I? That's like the classic King of Zamunda thing to say. And it's just so cool to see King of Zamunda here again saying, does the term images just mean the environment in which your software runs in? Not exactly, actually. It's a good question. But in this case, images is not just about the environment in which your software runs in. Think about images in a different way. Think about images as blueprints or templates for creating containers. And we'll be interacting with images very, very soon, so you get to see how they work in practice. We also have David in the chat saying hi from Mexico. Hi, David. The hardest part of Docker for me is remembering how to build the Docker files. Oh my gosh, very, very good point. And we're actually about to start using Docker files later in this project too. Yeah, thank you so much, Praneeth, for mentioning Docker images are templates that define the blueprint for an application's development and deployment environments. Yeah, I think Docker images and templates, you can like put an equal sign kind of there. So like Docker images equals templates for creating containers. Cool. So now we're going to verify that we've actually installed Docker itself. So let's open the terminal in your local computer. So in my local computer, in a Mac, I'm going to be searching for terminal. But if you're using Windows, search for command prompt instead. I think that's where your terminal will pop up. So I found terminal. I'm going to open it. And if you're wondering how I opened this window, by the way, you can totally access it just by clicking on Launchpad in your bottom bar. Alright, so you can try verify that you've installed Docker by running this command called docker -- version. Cool, and you can see in my screen that I have a Docker version shown here. Okay, so the moment that you see that you have a Docker version printed, it means you have Docker installed, it's working, it's great, you can move on. Now, you might run into a few issues, you might run into a few errors in this step. Don't worry if you do, it is completely normal too. And honestly, errors are just here to be learning opportunities. Everything is fixable, and we can help each other out, all right? So if you're seeing a command like Docker is command not found, you can start by trying to restart your terminal, restart Docker Desktop, and just try running this one more time. We also have a few other instructions, a few other tips on how you can troubleshoot yourself over here. So please go ahead and follow this if you're noticing a few errors or something that doesn't look quite right when you run Docker version. And of course, if you're still stuck, just ask the Nextdoor community. We're always here to help each other out as well. Cool. Thank you so much to everyone also saying hi in the chat. Really, really appreciate it, everyone. Okay. Next, now that we've verified that we have Docker itself installed correctly, we'll verify something that we've installed called Docker daemon or Docker daemon. I've actually had a little bit of a rabbit hole trying to research how to pronounce this word, daemon or demon. Turns out it's almost like a 50-50 split between both. How to pronounce Docker daemon? Like half of the internet is like, oh, you just say demon. It's just pronounced demon. The D-A-E is a D, demon. And then the other half of the internet is like, oh no, I say daemon. So please let me know in the chat how you say this word. I'm very, very curious. In the meantime, thanks so much, Joe, for being here. Joe says, I have a meeting to go to. Oh my gosh, that's so sweet of you to say bye. See you next time. So to verify that you have installed Docker daemon, all you have to do is check your system tray. And this is such a good time for me to show you something cool in the Nextwork learning platform. If there's something you don't quite understand, something you would like to get explained to you, you can do something called simplify like this. And once you click on it, you get a little bit of an explanation on the term that you've highlighted. So in this case, let's say we don't quite know what system tray means. Then what you can do is you can highlight it, you click on simplify, and now you know the system tray is a small little area on your computer's taskbar where icons for running programs and services are displayed. So that's kind of cool. All we got to do now is, I guess, follow those instructions. Have a look up top. What do we see? Do we see the little Docker icon? I do. I wish I could zoom in my taskbar, but unfortunately it doesn't quite work that way. But I hope you can see that there's a little icon here with a whale, and it has a bunch of little squares on top. And that really comes back to the analogy that containers and your host machine is kind of like cargo on a ship, where your computer is like the big ship that's running a bunch of different cargo that can all hold different things inside because they're all packaged into containers. Cool. Awesome work, everyone. So what is the Docker daemon? We can see this in the taskbar, which means that it's working okay, but what's going on here? So the Docker daemon is the engine that does a thing and actually creates the container, for example, when you run your Docker commands. In more technical terms, the Docker daemon is this background process that manages your Docker containers. It takes the commands that you send using the Docker client. For example, if you make clicks in Docker desktop about things that you want to do, you're kind of like sending commands using a Docker client. If you're typing commands into the terminal, kind of like when we typed in docker -- version just now, you're kind of like also sending commands again using a client. Docker daemon is the one that receives those requests, receives those commands, and actually turns that into the building of containers, running them, and distributing your containers. Okay, so the Docker daemon is like the engine for Docker that receives commands we send through clients. For example, clicks in the Docker desktop, or text commands sent in the terminal, and actually manages, controls the containers. It's kind of like the engine. So if you have a car, for example, I would kind of compare that to saying, oh, like, let us like speed up, and you kind of like push the gas pedal, and you kind of, when you push the gas pedal, it's kind of like you're sending this signal, you're sending this command that you want to speed up. And then the engine is actually the Docker daemon, like the car engine that's like, oh, okay, we're going to speed up, and actually speeds up your car. So in a very, very similar way, if you're like, oh, I want to do this using Docker, you can use the Docker desktop over here to send your clicks, send your commands, say, I want to create a container, or I want to do something. And then the Docker daemon is like the engine that's like, oh, okay, you want to do something? Okay, let's actually do it, and makes it happen. So let us click done here, okay? And let us now move into step 3, where we're going to learn how to run a pre-built container image. So now that we have Docker successfully installed, we're going to put it to work by setting up a container using a container image. Now, the purpose of this step here is really for us to learn how to use Docker to create, or really how to use Docker to create containers using container images. You're going to see this flow of having a container image and then telling Docker to create a container using that image very, very quickly with this step. This step is not where we're creating our own container image from scratch. In this step, we're creating a container using this image that's already been built by someone else. And then we're really going to see the power of containers, because we're going to say, hey Docker, can you run a container using this image that someone else has built, this template that someone else has built? And you're going to see Docker really just creating that container in seconds, and you being able to use the application, use the software in seconds too because of that. Cool. So in this step, we are going to create a container using a container image, i.e. a template or blueprint for containers. We'll get to see the power of containers as an application, as a working application. As we'll get an application to work in no time. When it's run as a container. Cool beans. So in this step, we're really going to create this container using a container image, which is like a template or a blueprint for creating containers. So in this step, we're going to use this template to create a container, and then that container is going to run, and then we're going to see how, because we've used a container for this, the application that's in that container is accessible to us very, very, very quickly, and we get to use it super quickly too. So let's click done for that, and let's just see that in action. So we're now going to come back to your terminal, and we're going to run this command that we're going to study a little closely in the next few minutes. Alright, so we're going to go into your terminal. Okay, terminal looking majestic. And then we're going to run the command, just like this. Cool. So, okay, really fun. So I've pasted the command in my terminal. I pressed enter on my keyboard, and look at that. So we have Docker letting us know, like, hey, I couldn't find something called Nginx locally, so here are a few status updates. Okay, we can go into these status updates in a second, but let's first try to understand what was the command we just ran. Alright, so what do these commands do? Docker run is a command that helps to start a new container. So here we're saying, hey Docker, can you create a new container for me? And we're going to be using this pre-existing container image, this pre-existing template for creating containers, and that template is called Nginx. Okay, Nginx. I think when you see this word for the first time, maybe Nginx is not the intuitive way to pronounce it, because I didn't really call it Nginx the first time, I have to say. But Nginx is the official way to pronounce it, fun fact. So we're going to be using this template called Nginx. And then we're going to also start this container in detached mode, which means that we can run it in the background. The important part about this is that this command, this part, -p 8080, basically means that we're going to map port 80 on the host machine, which is port 80 on the local computer. So for me, it's like my local computer, my Mac, to port 80 in the container. Okay, so port 80 in the container is going to show us, is going to help us access the web page that Nginx is running. We're going to see this in action very, very soon. But really, if you want to understand Nginx a bit more, just know that Nginx is this web server. So it is a program that helps us serve web pages to people on the internet. So once you have kind of like an HTML file, for example, or a file that can turn into a web application, Nginx is kind of like the server that you'll use to say like, hey, can you make my, can you display my, my file to people's like client, or like for example to people's browsers, and make it visible or available to people. So web servers are great to serve that purpose, and engineers use Nginx specifically because it can handle lots of web traffic very, very smoothly and efficiently. So for example, when you have a lot of people wanting to visit your application or people wanting to visit your web app, you can also even hear Nginx being referred to as a proxy server, which means that it can be used to forward requests from the internet, so lots of people wanting to visit your web app, and it can distribute that traffic equally to all of these different servers that are running your web app, so that everyone can have access to your web app without the web app like going down, or without the web app being slow for lots of people. So I hope that helps with understanding Nginx. If you have any other questions about it, add them to the chat, or anything that you like to share about what you know about Nginx, add them to the chat too. Alright, so now that we've learned what Nginx is, let's really understand what is a container image, because so far in this live, so far in this demo, we've kind of bounced around this concept that a container image is this template used to create containers. It contains the application code, the libraries, dependencies, other files that's needed to run the application. You can think about container image almost like this ingredients list, or this kind of recipe list that just says, hey, like this is a container that we want to run, and this is exactly what needs to be inside that container. You can make multiple identical containers from the exact same image. So what that means is when you spin all these different containers from the same container image, from the same template, all of those containers will end up behaving in the exact same way, regardless of where it is deployed. So if I've created an application and I built this container image for that application, now I get to almost like share that container image maybe with other people in my team, and they get to use that container image to run containers that can then almost like pretty much brings up my application, brings up my work in a way that it is running in the way that it is supposed to run. And all of my team members will now get the same kind of application or the same software that behaves in the same way, and it's just consistent for everyone. And that really solves that issue that we were talking about earlier in this live about how, it works on my computer, it works on my host because I set it up correctly, I've set it up for the container to run in the way it's supposed to be. Once you're using containers, everyone's computers, everyone's environment is technically running in the way that it's supposed to be, because the container itself already comes with all of those dependencies, already comes with all those configurations that pretty much make sure that your application, that your software is running in the best way. So with that being said, that's the reason why developers working in a team love to use containers. Cool. So what is Nginx? Ooh, how would you define Nginx? I'm actually very curious. It sounds like we actually have a few students who have used Nginx before. So if you have your own definition, if you have your own way of understanding it, I'd love to see it in the chat. I think also if you're able to write your own definition of something, if you're able to explain something back to someone else, it truly is just another level of understanding things. So if you have used Nginx before, just chuck in your understanding of it in the chat. And challenge yourself a little bit. I think it's a really good challenge. So let's give this a go together as well. Nginx is a web server, or you can say software that helps with serving web content like this. Cool. Nginx is often referred to, as a proxy server. Shout out to Merlin Devinda, by the way, in the chat for saying, I use Nginx in my daily operations. Nginx used for forward proxy and reverse proxy. It's really interesting. Ooh, this is cool. Marlon, I'm very, very curious. How would you explain forward proxy and reverse proxy? It sounds like you see it in your day-to-day. How would you explain it to someone that has never seen it before or doesn't know what it means? I'd love to see what you think of it. All right, thank you so much, Marlon. Cool. Nginx is often referred to as a proxy server, which means it helps with distributing traffic to your application across the instances running your... What are the instances running? Running the application. Cool. So next up is, what is a container image itself? This is a good question too. I mean, we've really been talking about it for quite a bit now so far. A container image is a template or a blueprint for creating containers. You would use, oopsie daisies, a container image is a template blueprint for creating containers. You would use a container image I would say actually, containers spawn? I think spawn is the right word. Or containers spawned, created, from the same container image will behave in the same way. Which helps with developers in a team having a unified experience. When they're running an application. Always! I think always within a few steps I will run into a text input where I run out of characters. I feel like this is a classic NAT situation here. So let us try make this a little bit concise. And a big shout out to Dari for saying hi everyone. Saying a big hi back. Cool. So a container image is a template or blueprint for creating containers. Containers spawned or created from the same image will behave in the same way, which really helps developers in a team. I think we can make this more concise, which helps teams of developers have a unified experience when they're running an application. When they're running the same application. I think that makes it even more precise. Alright, so what was the command you ran to start a new container? Do you still remember? Oh my goodness, kudos to you if you do. Or really the key command that helps with starting a new container is docker run. Okay, so we'll just say the command I ran to start a new container was docker run. I also, oh, really? We're doing this project together, so we're changing this to we. The command we ran to start a new container was docker run. We also set the flags -d -p 80 and jinx. My goodness, look at the things that we run in this command, guys. We also set the flags -d -p 80 and engine X. I just called it nginx live, didn't I? Oh my goodness, it's engine X. So we also set the flags -d, which means we're running the container in the background. Okay, that was the meaning of this -d. And we're matching port 80 in our host computer to the container, to the container's port 80. Cool, and that was the meaning of having -p 8080. I've run out of characters one more time, so let's quickly. The command to start a new container was docker run. Okay, and we'll finish this up like this. Yeah, thank you so much, DevOps methodology, for mentioning -d means it is in detached mode. Thank you very much. So yeah, when we say like in detached mode, it just means that the container will be running in the background. I love the phrase detached mode though. It's just such a cool phrase, and I feel like it's a cool like technical phrase as well to describe that situation. But yes, a big shout out to DevOps methodology, and thanks Amber for mentioning I think maybe the definition of container image, that you liked it. I'm glad you did. But actually a big shout out honestly to one of our features where if there's something that you're really thinking, oh, I would like more of an explanation for it, don't hesitate to like highlight it and try to see if you can simplify something or explain something even more. So for example, you can say, what are application code, libraries, dependencies. If this is new to you, you can try running simplify and they will explain to you, oh, these are the files that make up your application. So make the most out of this new tool. I highly recommend it. And it just helps you with exploring, what you're learning even more. So big shout out to this simplify feature. Okay, so you should get this response from your terminal, which is what we got as well, like this. And this is really saying, oh, okay, what's happened is Docker first looked for an image, a container image, a template in your local computer called nginx. It says, all right, let me go look for this nginx image that you want to run. And it said, oh, I can't find it locally. Looks like you don't have it. Okay, fine. Then in that case, I'm gonna look for it in my public library. And that's when it said, oh, okay, I could find it now. I can find, and I can even find the latest version of it. So it downloaded this image, and then now it's ready to go. Now we have run a new container that has, now we have run a new container using the nginx image. Solid work, everyone. And if you're wondering where that nginx image is really coming from, like it's just pulled from this random library, you can learn more about Docker Hub by clicking here and exploring it a little bit. You can think about Docker Hub as the place where containers can kind of just live and hang out, or really container images can just live and hang out in this like public space, so you can explore them. And in this case, now that we have run that container and we've also run it using a nginx container image, let us see it at work. You can open your web browser and you can navigate to HTTP localhost And that should take you to this default Nginx welcome page. Shall we give this a try? Shall we give it a try? Let's do it. I'm going to copy this, and then I'm going to run this in localhost. Ooh. Ta-da! It's looking really, really good. So you have this welcome to Nginx welcome page over here. And if you see this page in front of you, that is the best confirmation that you have the container is successfully running and Nginx is all set up all correctly on your computer already. You didn't have to install any other software that helps with running web servers. You didn't have to do anything special with configuring Nginx for your computer. All you had to do was you ran that one command that said, hey, Docker run, here's Nginx, and here's the port that you should map it to. And all you had to do next was visit localhost in your browser and boot. Just like that, you've seen proof that Nginx is already up and running and it's also working correctly, which is the important part here. So how did that just happen? How is it that when you type in localhost, you end up seeing the Nginx welcome page? So when you type in localhost in your browser, it means that you just want to connect to the server software that's running in your own local machine. You're not saying localhost take me to the internet, not exactly. You're kind of, when you type in localhost, you want to connect to the server software that's already inside your local machine. And when you have mapped port 80 of your machine to port 80 in the container that's running, this happened earlier when we ran this special little command over here. And do you see how that command contains -p8080 like this? This part of the command was very, very special because it was saying very, very specifically, can you please map port 80, okay, of the container to port 80 in this local machine, like connect those two together. And when you map those two ports together, what that means is now when localhost says, oh, I want to connect to the server software, it connects automatically to port 80 in your local machine. And then since you've mapped port 80 in your local machine to port 80 in the container, you've technically just put localhost, this request, in touch with your container directly. Okay, so now localhost is actually pointing straight to port 80 in your container. And now localhost is also listening. Where Nginx is working is because it's a web server, it's going to be serving web pages at port 80. So Nginx is kind of like meeting that localhost request at port 80 and says, hello, it seems like you want to run like this web page. Here you go. And it gives this Nginx default welcome page to this like localhost request. And then now we see that request load up in front of us in our browser. So this is really, really cool. Personally, I find this really cool because we really didn't have to configure too much just to see this going. If we had wanted to do this using virtual machines, we would have probably had to do a lot more. First things first is we would have had to set up a virtual machine, which means we would have had to configure like its operating system. We would have had to install that operating system into that virtual machine. And then there's also other software that you'll probably need to download to set it up so that it can handle a web server like Nginx. In our case, because we've used a container, what's happened is we've asked Docker to just run a container that already has that can already handle having Nginx on it. And then when that container is running, we also just got port 80 of our own local machine connected to port 80 of that container with Nginx inside. So we pretty much just had instant access to a functioning version of Nginx instead of having to use virtual machines to set up this environment that can let Nginx work. we just had instant access to this working version of Nginx already. So that's super, super handy. And let's try to figure out how we can build our own custom image in the next step. But I've also gotten ahead of myself because we should be taking a screenshot first. So let's take that screenshot of this Nginx welcome page, and let's answer one question as well. Cool, so let's take that screenshot now. Whoa, let's take the screenshot like this. Actually, maybe not. I think I've zoomed in too much. Let me zoom back out one more time. And let's take the screenshot like this. Okay. Boom. Looking good. And once you've uploaded your screenshot, you can answer this question. What did you see when you visited localhost? What are you seeing here? When we visited localhost, we saw, let's have a think. What do you think? Do you think you're able to share your own thoughts about what you're seeing when we run localhost and why it works, and how all of that was connected with the container? Give it a go in the chat if you'd like. And a big shout out to everyone in the chat as well for saying hi. Praneeth is giving a shout out to that simplify feature. I honestly am obsessed with it too. I think it's really, really cool. Shall we even get it to simplify localhost for us? Nice! This is so cool. I love it. So if you're really wanting to get to know localhost again, when you use localhost in a web server, you're telling it to connect to a web server running on your own computer instead of a server on the internet. Thank you so much for that explanation, Simplify. What is port 80? Oh my gosh, I'm addicted. Simplify. Cool. Port 80 is a standard port used for web traffic. All right, very cool. Okay, I see that we're feeling a little shy in the chat about this question, and that's totally okay. Let's answer it together. When we visited localhost, we saw the Nginx welcome page. This was because localhost, shall we use what the summarize feature gave us? This is because running localhost, nice. This is because visiting localhost tells our browser to connect to a web server running on our own computer. And since we've mapped ports, we've mapped to port 80 on the container, that server is Nginx. Phew! A fight to just 7 characters left in the text box, but I think we've made it. Very, very nice. Alright, build your custom image is our next step here. So what that step was all about just now was helping us get to learn that process of being able to grab this container image, this template, and tell Docker that we like to run a new container with that image. So what that means is I want you to run this container and have all of these things inside, which were defined by the image that we grabbed, and that image was called Nginx. So when that container is running, it has all of already the application code, all of the dependencies, all of the libraries required for it to be a fully functional Nginx web server inside. And what that means was when we were to call on localhost in our local browser, we were basically able to get access to Nginx, which is already working and functioning, because we ran it as a container and we didn't have to do anything else like super special just to get it to work. So that entire process was great for us to really understand the power of having container images. So we were using a very cool image that was already pre-built. But what if we're able to build our own custom image? And that's what this step is all about. We're now going to learn how to build our own template that we can later use as a blueprint for creating another new container. So this step is really all about let's create our own blueprint, our own template for creating containers later on. So in this step, we're going to just learn how to write the set of instructions that tells Docker how to build your own custom container image, and that instruction sheet or that instruction file is called a Docker file. And then afterwards, we're going to get Docker to read our instructions and then build the custom image. Cool. In this step, we are writing an instruction sheet recipe for building our own Actually, I want to say, in this step, we are writing an instruction sheet or how-to guide for building our own custom container image. Then we will tell Docker to read that file. So we're gonna say, in this step, we are writing an instruction sheet or how-to guide, and that's called a Docker file. And that instruction sheet is gonna tell Docker how to build our own custom container image. Okay, and once that's done, we will tell Docker to, hey, go read that file, go read that how-to guide that I've just set up, and create a container with it. Oh, to create a container image with it. To build that custom container image. Cool. So that was a small slip on my end. To be very, very clear, what we're building here is a container image. We're not building the container itself yet. We're building the container image. We're building the template. Very cool. Aman in the chat says, hello, Nat. Hello, everyone. Saying a big hi back. Cool. Okay, so in your local computer, what we're going to do now is we're going to create a folder and name it compute. So you can do this directly in your terminal by running these commands. And all we got to do, so I'm just going to make sure there's no existing compute folder on my desktop. And what we're going to do now is we're going to run these commands. Okay, press enter on your keyboard, and boom, we have just created a folder in our desktop called compute. So that's what these commands are all about. CD is basically saying, hey, you're telling your terminal to navigate to your computer's desktop, and at the desktop, you're going to make a new directory, which is like making a new folder called compute. So now that we are in our desktop and we are in the desktop and we've created the compute folder, what we want to create next is that Docker file. So again, the Docker file is that instruction sheet, that how-to guide for how to build your own container image. And how are we going to do that? Just by using commands? Well, it's actually just a 2-line thing as well. Your first line is going to be saying, oh, now that we're currently in the desktop, in your computer's desktop, can we navigate another file down, another folder down into the compute folder? So let's almost like double click or go inside the compute folder by using this command here. Okay. And now you're inside the compute folder. So now that you're inside the compute folder, we're going to say, all right, we're at the right place now. Let's create Docker file. And let's do that by running the command touch Docker file. Very, very cool. I'm very, very excited about what's to come. You can actually verify that you have Dockerfile in your compute folder now by going ls, which might be a command that could be completely new to you. If it's completely new to you, ls is basically a command you'd run in the terminal to just say, can you list everything out in my current directory? In other words, can you list everything that's in the compute folder for me right now? In this case, the terminal says, yeah, sure, let me just list it all out for you. You have Dockerfile in your compute folder. Full stop. I mean, it's the only file in the compute folder, so that's why we just have Dockerfile here as an output. But you know what? That's all we need, really. That's the single file that we've created in Docker in the compute folder, so we're happy. Okay, so this is great confirmation that you've successfully created that Docker file. If you're a visual person, you can absolutely try visiting your desktop, double-clicking on the compute folder you've created, and then just seeing, hey, do we have the Docker file in there? Is it in there? It sure is, all right? It's looking cute too. Okay, so you can see, you can see the Docker file over here inside my compute folder. All right, so now that we've verified that we have created this Docker file, I think we're going to be ready to, actually fill in the Docker file. So if you'd like, in your, I guess like click and drag kind of interface, you can just double click on Dockerfile to start editing it if you're using a Mac, or you can always try to right click it, find that open with option, and try to select a text editor. So for a Mac, it's like text edit, and for Windows, that would be like Notepad++. So once you've opened up Dockerfile, you can just fill it in using 3 lines. Yep, Dockerfile is just going to be 3 lines long for us. Are you ready to see and learn what those lines are? Awesome. So we have the first line says from nginx ... or :latest. We have copy index.html, and then this file path here as well. Okay, cool. And then we also have expose 80. Whoa, so we have from, copy, and expose. All right, interesting. Let's learn what these commands mean. Okay, so the first line, from nginx latest, this one over here, basically means that we're going to start our Docker file by copying, actually, another container image out there. So don't forget that a Docker file is here as kind of like an instruction sheet, a how-to guide on how to build your custom container image. So we're going to say, hey Docker, to build my custom container image, we're actually just going to copy the latest version of the nginx container image first and foremost. Okay, so we're going to use that latest version of the nginx image as kind of like our base, and then we're going to make a few modifications, we're going to make a few changes to that nginx image, and then once I've made those changes, that version of nginx, or really that copy of nginx, is my own custom image. So really, this custom image that we're creating today is created from this nginx image as its foundation. We're kind of like creating a modified version of the latest nginx image, and then we're gonna just call that our own. That's our custom image now. So very, very cool. We have Glow in the chat saying, are you at the office or somewhere? I am in Nextwork HQ. We also have DevOps methodology saying, automation of Docker image creation. Basically, it contains a set of instructions. Ooh, is that your definition of one of the terms that we were explaining previously? Very, very cool, DevOps methodology. I'm loving your work. This is super cool. So we already have from nginx :latest telling us that this container image that we're trying to build, that we're trying to create, is going to have the Nginx image at its base. Do you still remember what Nginx does? Or what this Nginx image does? We've literally just run it in the previous step. It is a web server that we can use. Copy index.html in this cool little file path over here. What's going on here? All right, so what's happening here is we're actually saying the next thing you're going to do, okay, we're telling Docker that the next thing you're going to do is you're going to copy index.html, which is a file that we're going to create in just a second. And you're going to paste that copy or put that copy inside this folder in the container that you spin up. Okay? And this is pretty much one of the main ways that we're customizing that Nginx template or that Nginx image that we're copying here. We're basically saying we're making a copy of this Nginx container image, but instead of using the default HTML file that's stored in the container's HTML folder, can you please make a copy of the index.html that I have locally in our computer, and can you put that in there instead? Because I want my Nginx web server to be displaying my web page instead of that default welcome page that we were seeing just now. When we were running localhost, we just saw this default welcome page. I don't want to see this anymore. I want to customize it to my own web page. So can you please put my index.html and put it in there instead? So this is pretty much one of the ways that we're customizing it and creating our own custom image. All right, next command. Next command says expose 80. Cool. Expose 80 is basically saying that we want the container to receive web traffic through port 80, and that makes it very, very easy for users and other services to read your web app as well. We're going to just remember this expose 80. It's going to come through very, very importantly in the next step as well. Save your changes to your Docker file by pressing Command or Control S on your keyboard. Command S or Control S. Okay, save that work, and let's take a screenshot as well. Very cool. So now we've uploaded that screenshot. Let's answer a few questions together, shall we? First question. Ooh, let's see what the first question is. The Docker file is a set of instructions that tells Docker how to build your custom container image. What do the 3 lines in your Docker file do? Oh, very lucky that we have those 3 lines right in front of us then. So our Docker file tells Docker 3 things. First, our custom container image uses the Nginx, or really the latest version of the Nginx, uses the latest version of the Nginx container image at its base. Then we're modifying this base. We're making modifications on this base by saying we want the Nginx web server to serve our custom Whoa, I ran out. I only have 3 characters left. Okay, so then we're modifying this base by saying we want the Nginx. Then we're modifying this base by replacing the default Nginx welcome page with our own custom index.html. Perfect. Alrighty, let's click done. Okay, so now that we've created our Docker file, what's next for us? We're going to create the web page for your container. Remember how we said we're going to create index.html later? Okay, now is later. Now is the time where we're going to create that index.html so that later on when Docker is creating a container, is creating the container image, it knows exactly what you mean by copying that index.html inside this folder of the container. Cool. So now that we have your Docker file ready, what is the web page your Nginx server should serve? That's the index.html file. That's the web page that the Nginx web server will serve. So let's run these commands in the terminal here to create a new file named index.html. Okay, so you should be familiar by now that what we have over here is we're trying to change our directory and navigate into the compute folder. We should be there right now actually. If we were to run ls, yep, that tells me I am in Docker file. If we were to print our working directory, that's another command you can learn. pwd basically tells you exactly which folder you're in, and that tells us that we're actually already in the compute folder. But if you want to learn how to navigate in there just using the terminal anyway, let's run this command, and again, we should be inside the compute folder in your desktop. Now we're going to run touch again, which is the command for creating a new file basically, and we're going to say touch index.html. Now what's going to happen when we run ls? Aha! Now that when we run ls, it's no longer just Docker file, alright? In our current directory, it's Docker file, and there's also index.html, so we have 2 files now in our directory. Very cool. Okay, so if you're wondering if you've never used an HTML file before, just know that an HTML file determines what your web page will look like. It's this document that lays out the web page's layout, the text, the images. It basically commands, or it basically is your canvas for kind of deciding what your web page should look like. And really a lot of today's web pages, whatever you're looking at, you can save like an HTML file of it, and when you save it, you'll be able to read like, oh, so this web page is made out of this heading, it's made out of this header that's placed here, this image is placed here, oh, these like paragraph text. So it's almost like the structure of a web page in this one file. It's super cool. When Nginx opens your HTML file, it will just read the code that's inside, it will read what you've defined that's inside, and just display it on the browser and makes it look very, very visual. So we're going to open that index.html file that's been created. So let us click on the compute folder in your desktop, and then click on that index.html file that pops up. Okay. And you're going to notice, oops, what's happened is it's actually just opened my index.html file and just loaded it into my browser straight away, which is not what we want. As you can see, there's nothing to show. Our index.html file is empty. So what we want to do instead is we want to right click on that HTML file, and we want to select open with to open it with our text editor. So that's text edit if you're using Mac. Okay, so we should be using text edit now, and ooh, here we go. Index.html looking cute. Let us now head on to the next step, where we're actually editing the content inside our HTML file. So it's no longer empty, you know? Alright, so what you can do is you can copy the code that's in this block over here and paste that into your index.html file. Looking cute. Hello from your name's custom Docker image. Whoa, very, very nice. Let us use someone's name over here. A big shout out to Aman for saying hello everyone. So hello from Aman's custom Docker image. Very, very cool. Shall we see if we can even add another header inside just for kicks, just for fun? Hello from Erwin. Hello from Erwin's custom Docker image too. Cool. So now that we have this HTML file here, we're going to build the image. Okay, so we're going to build the image and create the template that we're going to later use. And then Docker will later follow the template, follow the image that you give to Docker to say, oh, okay, I'm going to create containers based on that image that you've given me. So let us copy this code that's inside and let's run it in the terminal. And what that does is Docker is going to read the Docker file that you've created to create the image itself, to create the template. Okay, very cool. Whoa, it's looking pretty packed. Very, very quickly, we have a good scan of a few status updates from Docker as it creates that image for us. That's looking pretty cool. Cool. Oh, okay, cool. So if you are still wondering what does building an image mean, building an image means you're creating a Docker image using those instructions in a Docker file. Docker will then use the built image as the blueprint to create containers that run your application anywhere. Awesome. So just now the commands that we ran over here was Docker build. So we're trying to say, Docker, can you build this container image? Okay, and -t says my web app. So we're gonna say, we're gonna call that image my web app, and you can just find the Docker file that you need to get all the instructions for building my image in the current directory. So that dot just says, look at my current directory, grab the Docker file that's in that that's in this current directory, read the Docker file, and then with the container image that you build from those instructions in the container from the Docker file, call that container image my web app. Okay, so we've just run those commands, and it's super cool to be seeing something like 2-2. Look at that. It says copy index.html into this location. That's exactly one of the lines that was in our Docker file. Whoa. That's exactly one of the lines in our Docker file, this here. So it really shows that right now, Docker is following the instructions that we've written to build the container image. Okay, cool. All right. So all of these responses is kind of like Docker's status updates on how it will build the image. And when that's done, you can answer this question over here. Oh, awesome. Thank you so much to everyone in the chat for talking about Docker and Docker files as well. DevOps Methodology has shared some advice that you can use Dockerfile and set up Jenkins in a CI/CD pipeline. You can also create a Dockerfile. So you can create a Dockerfile and then from that image, automate in Jenkins. Okay, very, very cool. DevOps Methodology also mentions, hey Natasha, can't we directly use VI editor in the CLI? Ooh, very, very good point. Is this something that you've had personal experience with, DevOps methodology? Do you find that it's even simpler, even more efficient than what we've done so far? Let us know your thoughts. I'm very curious to hear about your experience with this. Okay, very cool. I've also just realized that I've zoomed in a little bit too much in some of the instructions. So really sorry about that, everyone. And I'll be a bit more careful for the rest of this live. Thank you so much for your patience with this. I will make sure that the rest of the instructions will be very, very easy to read. Okay, in the meantime, how did you build an image? Remind me to zoom out after this. How did you build an image with your Docker file? So the command I used to build a custom image with my Docker file was ... The dot at the end of the command means ... Alright, so the command we used to build a custom image with our Docker file was docker build. The dot at the end of the command means that Docker can find the Docker file in the current directory, i.e. the compute folder. Cool. So let's click done and finish that off. So now we're ready to run an image, run a container, and we're really here to use the custom image that we've just built. Look at that. It's already, building has finished for this image. So we have this template in the world now that has our, this template for first, like having basically a customized version of the Nginx server that should be loading our custom index.html page. And the other thing is also that it should expose port 80. So let's run a container that is based off of that image, based off of that template that we've defined. Cool. So in this step, we're going to run the custom container image, and you're going to see a web page in action with that. Oh, cool. Thank you so much for Desiree for mentioning that for Windows users, touch command is not recognized in the command prompt. Instead, we can use echo and then that arrow key file name. Interesting. Let me make a note of that, Desiree, so I can also add that to our step-by-step guide. This is a very, very useful tip. So I will look into that. Thank you, Desiree. So in this step, we are going to use the custom container image that we've built to create containers based on that image. Based on that image. Cool. Very nice. We'll just click done for that and let us run an image using this command over here. Lovely. This command says docker run -d-p 8080 my web app. Doesn't that look super familiar? Doesn't that look super familiar? We've run a very, very similar command in step 3 when we ran a pre-built image. So let us run pretty much the identical command, but this time the image name is not Nginx at the end. The image name is now my web app. Do you still remember seeing this command in step 3? Look at that over here. Docker run -d-p 8080 Nginx. What are we seeing now here? Docker run -d-p 8080 my web app at the end. So that's where it's different. everything else is actually the same. And unfortunately, we've run into an error. Looking at this error message over here, can anyone in the chat already understand what's gone on here? Why have we run into this error? What do you think's happened? What do you think has happened? Alright, so what's happened over here is the error message is telling us that there is already a container that's out there using port 80. So the new container that we're running, docker run, creates a new container, don't forget, is not able to access port 80. Oh no. A big shout out to everyone that's already saying change the port. Salo saying the port's already used by something else. Erwin, a running container is already using port 80. Wow, perfect answer. Med, we use port 80. Wow, everyone is like on to it. Port is already attached with another service. Which port is it? Which port is it? Oh my god, I feel like I spoiled the answers in the right hand side of the screen. But which port is it that's already using up port 80? What do you think? Can you already tell which port it is? So we can find out as well by checking out Docker Desktop. So don't forget that Docker Desktop is this handy little tool that helps us with using Docker more efficiently, more easily. And let's see what's happening here. All right. So we can see here that, we can see here that we should be in containers. All right. We have a little container over here called Nginx, and then we have our container over here that's called Tender Ptolemy. How do you even pronounce that? What a cool word. I have no clue how to pronounce that word. But we also have another container with an equally interesting name saying Pensive Vesvaria. Very cool. I love these names, and they're also telling us some interesting things because they're also telling us what image was used to create these containers. In this case, we're told that this first container, we used Nginx to create it, and in this bottom row, we used the My Web App container image. And who created that container image? That's us. We created the My Web App container image, and we created a container with it. And what's happening here is you can see that their colors are different. All right, so something's happening here. What we'll find out is that the port that they're using, is 8080 for the top one. So when the bottom container, the bottom one that's that was created using the My Web App image, can't use 8080 because it's already been taken up by the top one. And that top one, that top one is that initial welcome to Nginx welcome page that we were seeing. So because this container that we spun in step 3 is still being used, it's still running, it's taken up port 80, and it's basically blocked off our new container from using it. Let us stop this container. We can say bye-bye to it. We can say thank you so much for your service. We're going to move on to our own custom container image. So we can stop it right away by just clicking on that square icon under the actions column. So let's stop it. It's gone now. It's no longer running. So what's going to happen when you visit port 80. Can you still see it? Oh, it's still stopping. Oh, it's exited now. What's gonna happen when we run localhost again? Oh no, it's gone. The site can't be reached anymore. Okay, when you use localhost. And why is that? Because we have stopped running the container, which means the web server, the Nginx server, stopped running too. Okay, so that's gone. Well, the good news there is, now that port 80 is freed up, we can actually start to run this container that was created with the My Web App container image. So let's start running this, and let's visit port 80 one more time. What are we going to see now? Whoa, look at that. So now that we're loading this, we can actually see our index.html file looking cute. It says hello from Aman's custom Docker image, hello from Erwin's custom Docker image. Looking nice, everyone. I think that looks great. Oh, don't know how that happened. That was interesting. I feel like I just clicked on the 8080 link, and it actually took me to the Nginx. I wonder if this is a caching thing. Could it be caching? That's still taking me to the Nginx. That was still taking me to the Nginx webpage. I guess it was. I had to do a hard refresh. I have to press Command-Shift-R on my keyboard so that we can refresh localhost again. And we're kind of like shaking localhost. We're like, wake up! And localhost is like, oh yeah, I was loading like your old settings. Localhost is now this new index.html file because this is what is the HTML file that's inside the Nginx web server. This is now the HTML file that our web server, the Nginx web server, is serving from within the container. And yeah, it's very, very cool to see our file that we've custom created just now live and working. So that was a big success. And let us try to explain the error that we ran into. Okay, very cool. So there was an error when I ran my custom image because I resolved it by, alright, let's give it a go. There was an error when we ran our custom image because we tried to map our port 80 with the new container's port 80, but that was already a running container was already using port 80. We resolved this by stopping the running container so that we can start our new one. Our new one, like this. Is that possible, team? So that we can start a new one. Alright, let's save that, mark it as done, and let's move on to the next bit. Okay, so we can see the content of the index.html file. Perfect. And let's recap. Can you tell the difference between containers and container images using what we've just run? So in this example, the container image is kind of like the template. It's like a set of instruction that tells Docker how to run this web server. Well, really, the container image, instead of like a set of instructions, it's really almost like a template more so. it's kind of like Docker is going to look at the container image and say, oh, now that I see the Docker image, I know what is the type of container that I should be running, what should be inside the container that I run, that I spin up. So it's going to create this container based on all of the details, all of the requirements that are listed inside the container image. And once it's created that container, okay, that container is running an application that was already defined by the container image itself. So that's the difference between the container image and the container. You can think of the container image as this template that will live on and on and on for this container image you've written once, or you've built once. And the containers that you create are literally from Docker looking at the container image that you've built and saying, oh, okay, we're going to create containers based on this template that you've made. And containers can be stopped and started all the time, but container images probably won't change too much once you've created that container image. It's so that when you make new containers based off of that container image, those containers really should be behaving consistently with each other. So the container image itself doesn't really change, so that there's a lot of consistency with all of the containers that get created from it. So I hope that was clear. And let's take a screenshot of our browser showing the contents of the index.html file. I'm super happy with this. I'm really happy to be seeing Aman and Erwin's name on it too. And let's take that screenshot. Cool. Let's stick that in here, and let's add another explanation. Very cool. So what's the container versus the container image here? Oh, perfect. We just talked about this. So I think everyone in this live should be able to explain it now. In this example, the container image is the template for creating a new container running an Nginx server that serves our custom index.html file. Perfect. The container is the actual software that's running an Nginx web server with those specifications. Detailed, with those specifications or customizations, like that. So enter that, and we'll move on to our very final step. Remember what I mentioned about how we're about to work with Elastic Beanstalk in the very final step of this project? Well, we're here now, and let's do this. In this final step, we're deploying your custom Docker image to AWS Elastic Beanstalk, and this service makes it very easy for developers to deploy applications that's in the cloud. So you can think of AWS Elastic Beanstalk as a completely different service from Docker, okay? So let's not mix the two, let's not confuse the two. Docker is here to help you create and manage containers. AWS Elastic Beanstalk is here to help you deploy applications to the cloud. So they do completely separate things here, but Elastic Beanstalk is still in some ways related, somehow linked to containers, which is why we're using it in this project, and you're going to find out how. So this step is truly the grand finale for the project. We've started with figuring out how containers work, but really in kind of like the application development life cycle or the application development process, it's very important that once you have built kind of like the source code, and in our case it's kind of like the index.html, we found a way to make it very, very easy for it to be shared with other developers, using containers. And then now that we have also found a way to containerize our application, we can also use that containerized application and deploy it with Elastic Beanstalk so that it can be available to the world. Okay, don't forget that at the very start of this live, we've mentioned that containers are very helpful in a setting where you're working with other developers, you're still working on the software, you're still coding it, and you want the entire team to be able to work in a similar kind of environment, and the application is behaving in a very consistent way for everyone. Now what we want to do is we want to actually make this application available to the world now. You're saying, okay, it's ready for the user's hands, it's ready to be in the hands of the users, so let's get it out there. Okay, so how are we going to do that is we're going to learn how to set up this application in Elastic Beanstalk, and then we're going to just deploy the application right away using Elastic Beanstalk. So in this finale, in this final step, we are going to set up an application in Elastic Beanstalk, which will help us deploy our containerized, which will help us deploy our web app and make it available to the world. Okay? Alright, so now we finally get to come back to the AWS Management Console. Oh my goodness, where we started at the very start. Don't forget that you're still logged into your IAM user, and we're going to start by visiting the Elastic Beanstalk service. If you didn't know how to find it, just use that search bar at the very top and type in Elastic Beanstalk like this, and you will be able to find it and click on it straight away. Cool. So we mentioned that Elastic Beanstalk is really the service that makes it easy for you to deploy cloud applications. And it makes it easy by taking away a lot of the work related to handling the underlying infrastructure of a cloud application. All you have to do when you're using Elastic Beanstalk is you just have to upload your code, and Elastic Beanstalk truly helps you handle everything needed to get it running. Things like setting up the servers, things like setting up the databases, like the connections to the databases, things like setting up a way for you to scale and security, monitoring. So it's super, super helpful. And what that really does for a developer, does for engineer, is it lets you focus on your application code without having to actually spend too much time on the cloud infrastructure itself. You kind of want to just focus on, I just want to focus on how, what the cloud, what my application is going to do, and also what my application is going to look like. I don't really care too much, or I don't really want to spend too much time on figuring out the how of getting the application in the hands of your users, or in the hands of our users. Cool. So let's jump into this by, there's a bit of an issue with the formatting here, but think of this as a bullet pointed list. In more technical terms, Elastic Beanstalk does handle things like capacity provisioning, auto scaling, monitoring, load balancing as well. So the reason why we're even using it in this step is because Elastic Beanstalk can run applications that are packaged as Docker containers. So this means you can develop your application on your local machine. Okay, this is what we did when we created the index.html file. You built that Docker container image to package everything you need to run it. And then once that image is ready, you can just deploy it deploy your application using Elastic Beanstalk. Cool. So what is Elastic Beanstalk? And give yourself a second or two to think about how you'd explain it to someone else. Awesome. Elastic Beanstalk is an AWS service that helps with deploying applications to the cloud. It abstracts away a lot of the work with setting up cloud infrastructure, when deploying applications. Alright, so now that we're in the home page for Elastic Beanstalk, what we're going to do now is we're going to click on Create Application over here, and let's get started. So an Elastic Beanstalk application, it's just like a folder that contains all of the different versions of the exact same project, the exact same software that you've deployed before. This application is also it will also store all of the settings and all of the configuration you've used to deploy them. You're going to see that there are a lot of steps right now when you visit Create Application. You could be thinking, oh my gosh, there's way too many steps to create this application. But just know two things. One, it is extremely simple to go through this process. We're going to go through it together step by step, and you're going to see that a lot of the things you can just leave the default values and you'll be all sorted. Two, like we've mentioned before, Elastic Beanstalk applications save, and they just contain all the settings that you've used to deploy different versions of the same app. And what that means is when they save these settings, you don't really have to configure this every single time you want to deploy an application, because a lot of this will just be, oh yeah, let's just use the same settings as last time. So all of these steps here are just about what kind of customizations what kind of customizations you like to use when you deploy this application, and we'll be explaining every single page as we go as well. Cool. So please make sure, in classic Nextwork style, we like to go through and just explain everything. Really, in this case, we kind of like to explain, all of the different sections of this process. But it's absolutely not required for you to understand every single thing you're about to see. It's more the fact that this can help you understand Elastic Beanstalk. And really the key thing to note is just understanding and noticing how simple it is to upload your containerized application to deploy it. Cool. So give this another go, have a little read if you like, or take the time to make it to this page, and we'll get started in a second. All right, very cool. So in this very first page, this is called the configure environment page, and what's going to happen here is this is where we almost configure the settings for the virtual machines that will be running your application. So when you configure your environment, you're essentially deciding things like, oh, what kind of or what types of EC2 instances will actually run my application? How many instances do we want to run? How is that number going to increase and decrease with changes in traffic? And you might even come across network settings as well, but I have a feeling that actually might come through in configure instance traffic and scaling, actually, these two parts. So really what's happening here is you're configuring the type of EC2 instances that you want to use to run your application. At the end of the day, Elastic Beanstalk is using EC2 instances under the hood when it runs your applications. You're not really creating that EC2 instance manually because, again, Elastic Beanstalk is going to do that for us. But even though the important thing to know here is, even though you're kind of like deploying a containerized application, you're kind of deploying a Docker container, what automatically is going to happen is that is going to run on an EC2 instance that's managed by Elastic Beanstalk. So at the end of the day, there's going to be EC2 instances in the equation. We are going to be using those instances to run the containers. So let us give this application name a name. Let's call it Network App. And we'll leave the environment information as it is before moving on to platform over here, where we will say, let's go for Docker, the Docker platform, and leave these recommended platform branch and platform version. So the platform really is the technology that will actually run your application. So we know what is going to be the EC2 instance, which is kind of like the wider kind of operating system that we're going to be working with. But here, the platform is the actual technology that's going to, in your EC2 instance, open and run your application. We've picked Docker, classic choice, because it really is the best platform for deploying container images that were built with Docker too. Platform branch, which you're seeing here, and platform version is kind of like just being very specific about which version of which type of Docker you want to be using here. Okay, so once you've specified that you're going to use Docker, what we're going to do next is we're going to go into the application code section. We're going to click on upload your code, and we are going to head back to our HTML page. Oof, where did it go though? Where did it go? We're going to head back to our HTML page. Make sure you're opening it with text edit or your text editor. Okay, and let's make one more edit so that when we see that one more edit in the final outcome, you can really have confirmation that the version of index.html that is being deployed is the right version. So let's just say, what's another name that's in the chat? Let's have a look. Oh, cool. Wow, we have Desiree as well, of course. I feel like let us mention Desiree as our new name in this file. So hello from Desiree's custom Docker image. And now we're all going to work together as a team to just keep an eye out for this line when we deploy the application and see it live in the internet. Does it say this line correctly? So let's have a look, shall we? Okay, so we've updated our index.html file, and it tells us that Elastic Beanstalk needs your source code to be in a zip file. Okay, so what that means is the HTML file and the Docker file over here, they need to work together to become a zip file. I personally use Compress on my MacBook for this, but use whichever tool helps you with compiling or compressing something into a zip file. And when that's done, what you'll have to do next, oh, don't think that's the right place actually. We actually should be going into our Elastic Beanstalk setup page. We're actually going to say, let's give it let's upload our work first. We've compressed it. How can we find it? Easy. We can find it in desktop, in the compute folder. Off it goes. And the label for this is honestly not something that will really change how your web app will work. It's truly just a label for you to recognize, oh, what version of this am I, what version of my application code am I using? We don't really have too much to add on here, so you can do a generic version 1 like this, or if you'd like, you can save. You can be like, oh, this version uses Aman and Erwin, and I think Desiree as one more line, but we'll see it in action very soon. So you can say, oh, this version name is Aman, Erwin, Desiree. That can totally work as well. So we've uploaded our zip file as the local file containing our application source code, and also the Docker file. And we've also included a preset here, which is basically a predefined way to set up Elastic Beanstalk. Now that we're going to tell AWS that we're really here to just do something that's free tier eligible, what's going to happen is the default selections next are going to be very, very like free tier eligible friendly, or very, very simple, so nothing too complicated there. Very cool. Oh, all right. So next up is configuring service access. If I'm not wrong, everyone should have a new service role that they can create here. And then use the default service role name, which should look like this. I have to confess, I think I already have a service role name with the exact same name in the first time I tested this project. So I will just put a 2 behind that, and hopefully let's not forget a second time to delete this after the project finishes. So under the service role name field, we are seeing that there's something else called an EC2 key pair, which we can safely ignore. We don't really need direct access to an EC2 instance so far, so we're actually okay. But if you'd like, you can always add a instance profile too. So an instance profile is kind of like similar to a service role. A service role is something that lets that kind of gives Elastic Beanstalk the ability to call other AWS services in your behalf. For example, if you give it the proper like service role permissions, what's going to happen is the Elastic Beanstalk application will have the permission to access other AWS resources. Cool, that's very, very helpful. Well, we're going to ignore this EC2 key pair dropdown, we don't need it, but instance profile wise, let us choose ECS instance role. And instance profile over here is basically another kind of IAM role. It's kind of similar to service role, where we are kind of giving it we're kind of giving Elastic Beanstalk permissions here, but for here, instance profiles is designed to give EC2 instances this time the permission to access other AWS services. So in this case, we've selected ECS instance role, and what that does is it also gives our EC2 instances the permission to manage containers, technically, using something called AWS ECS, and we'll learn more about this in a future project too. Very cool. In the meantime, let's move on to that next page, and let's talk about networking database. This one is going to be super, super simple, and the reason for that is because we don't have anything too different to do here. I think the biggest thing here is to just make sure that there is a public IP address, so that when your EC2 instances and the application is actually accessible from the internet. If you don't have this activated, that means servers from the internet won't be able to find you, at least from public IP addresses. Cool. Now we don't need to skip. Now we don't need to use the rest of this page, so we can skip safely. For example, we won't really be connecting this web app to a database because we've done that in the previous project. Okay, very nice. Well, we're kind of getting closer, guys. So just 2 pages left. under root volume, what's going to happen is we're actually going to be picking general purpose 3, and this is a free tier eligible tier. The size should by default be 10 at minimum. It can't go any lower than 10. So we'll just keep these default values here, which are already the lowest values. Cool. We can also make sure that under here, IMDS, that we just keep this deactivated. If you've never used IMDS before, just know that it is an extra for experts definition, but what you'll need to know is that it gives temporary credentials to EC2 instances, which we don't exactly need, so we won't be using that here. Alright, we also don't need to configure anything else on this page. EC2 security groups helps with controlling traffic, whilst capacity is something that pretty much controls the scaling settings, the ability for it to get to this many instances if you reach this amount of traffic, things like that. We won't be needing it again today because this is a quick project where we're really just trying to see the effect of deploying an application that you've built a container image for. So we don't really need to linger here for too long, although if you ever need more explanations, you know where to go. You can literally just highlight these and click summarize, and soon enough you'll get some great definitions, I'm sure. Okay, so final page pretty much before the review. This is some health reporting stuff that we just want to select basic for in this case, so that we don't get charged. And do we need to get any managed platform updates, which costs money? I don't think so, actually. I don't think we need to activate this at all. Managed platform updates is really here to help us automatically just update any software that's running the application in Elastic Beanstalk. In our case, we don't really need that, again, since we're about to wrap up this project after this step. So, what shall we do next? I think next up is just understanding that when you're deploying a application, there's also different timings of deploying the application. One is called all at once, which means let's just update all the instances that are running our application at the same time, even if it risks having like a small amount of downtime where no one can access the website. At least you're just deploying everything at once. You're not waiting too long, and you can pick up on issues faster since they're deployed to everyone even faster. So those are some reasons for picking all at once. And there's also rolling updates. You can't actually see it here, but one of the other options is rolling updates, which means the instances will just get upgraded over time, which is probably a little bit slower. But what it does is if the first group of people that you roll it out to has an error, ideally by the time you launch your 4th cohort, for example, for this deployment, that a lot of the issues are already sorted. Cool. This platform software at the bottom here, we can also leave as default. And there's also an explanation here if you're curious. But let us press next and move on as soon as possible. That's because, if I'm not wrong, it will take a few minutes after you review this. Elastic Beanstalk and the application itself takes a little bit of time to run, to set up. So once you review this and you use this little checklist to just make sure everything looks correct, your application name, application code, zip file, EC2 instance profile, can you see it? ECS instance role looking cute there. We have our public IP address set to true. Okay, over here. Do we have a root volume type that is GP3? Okay. Do we have an environment type that is set to single instance? Do we have our system that's set to basic? There we go. Basic. And I think we also have two other things to mention. One is managed updates should be deactivated, and also the deployment policy all at once looks great. Very cool. So let's give this a go. Let's press submit now and wait 1 or 2 minutes to get it ready. Okay. We won't wait too long though. It's launching the environment, but in the meantime, let us better understand something that's at the last part of this project. We can do it now if we want, or we can answer this question. How long did it take to deploy your image to the world? How long did it take for the first few parts? It would have been 3 minutes maybe. Deploying our custom image with Elastic Beanstalk took us, how long did it take? Alright. Deploying our custom image with Elastic Beanstalk took us, I'm going to guess 10 minutes total. This includes the time it took to launch the Elastic Beanstalk environment application. Cool. Alright, I can't wait to take a screenshot very, very soon. It's still launching, which is totally okay. I think what we could do instead is to work on that very, very last question at the end of every project. In this case, we can mention that in this project, we used Docker to, oh my goodness, what do we use Docker to create containers based on container images and set up our own container image. All right. Without further ado though, a big congratulations to us for getting the environment to run straight away in our first try. That's super satisfying. Shall we take a screenshot now? Oh, maybe not of this, but maybe of the domain. So what we've done so far is we've deployed the application into the world, but where is it in the world? Well, thankfully there's a domain already set up for us. All we gotta do is click into here and see what comes up. Whoa, look at that! That looks really nice, everyone. You can see we have Ahmad and Erwin, names that were mentioned before we edited our file for one more time. And look at that, we did just update the file for one more time to welcome in Desiree into this piece of index.html. But we went, created a container image using this, and now look at it now. Cool. So I think we can upload a screenshot now of the deployed application. So let's give that a go. Very nice. And next up, we can submit this right away since we've mentioned how long it took us to deploy the application. Would you say 10 minutes is pretty accurate? How long do you think it would take you to deploy this application to deploy this application yourself with the help of Elastic Beanstalk? Okay, so we have wrapped up the main part of today's project, but we're honestly not done yet at all because we need to delete our resources to really be considered project done. So we'd always highly recommend that you just stop the step-by-step guide here, stop the video right here, and try just delete all of the resources you can remember as much as you can, and we'll see how many resources did you leave out. Was it 1 or 2? Was it many? Let's see. Cool. So the first thing to do is to just remove the environment that Elastic Beanstalk has set up to run the web app. Well, in that case, let us click on Actions here and let us terminate the environment. So the name of it is bolded up here. So use that to your advantage, and you can just paste that in here as a name of the environment. Okay, terminate that. Done. So we've terminated the Elastic Beanstalk environment. And now we can also delete all the resources, associated. We don't have to delete those. The fact that we're deleting the entire environment is already enough that it would delete all the resources inside it that relies on it. And now we can actually remove our containers and our container images. It doesn't actually cost money at the moment to store containers in Docker, but it's still really, really good practice to know when to remove resources you don't think you actually use again. So back in the terminal, we're going to run this handy little command that's going to help us save a lot of time. It says docker ps-a, and it lists out all containers that I've even run or stopped. Okay, so it really should say docker, okay, ps-a. Let's run that. Oops, I think I might have accidentally added a 0 to the end there, but let's run that, and whoa, there we go. So what we ran just now was, can you just print people's container IDs and the images that were used to build, to create those containers? It's kind of just like the exact same view as this here, because you have the container ID over here, and then you have the image, what was the template that was used to create this container, and you can even stop them here. So you can actually delete containers straight from this Docker desktop, and doesn't that just go to show how visual and how, I guess, beginner friendly it can make using Docker desktop feel like. But in this case, let us quickly stop the containers that are running. You can immediately just write docker stop like this and copy the container IDs that show up. So in my case, I would just go docker stop, and that first ID looks like this. So let us copy this ID and paste that in here. Off it goes. Next one, which one are we going to stop? Well, the Docker desktop actually gives you a hint. Both of these are stopped already. The other one hasn't been running ever since we stopped it to save ourselves from that port 80 confusion. But now that that's done, we can also even remove images, because we had to install the Nginx. We had to use the Nginx image, and then we even created our own image. So we can actually remove those by, again, running the command called docker images like this to see them all listed out. Okay, and now again, we can use this command called docker rmi to remove images based on their IDs. So docker rmi. Alright. So we have a bit of a daemon conflict here, but that's okay. Let's see if we can resolve it later. In the meantime, let me see if I can go docker rmi for the other image. We have an error response. We have an error response when we try to remove these images, when we try to remove these templates. Why is that? We have something that says unable to delete it because the image is being used by the stopped container. What do we need to do next? What do you think? we have a stock container that's using these images, and that's stopping us from deleting the images altogether. What do you think is going to help us? What we're going to do next to give this a try is to just delete the containers that are running those images. So let's have a go at running, now that we've stopped these containers, let's see if we can actually remove them, literally just delete them. So that's actually docker rm, and the first container ID we'll remove is the one that was created using the my web app image. Okay, when it spits out this as a response in the terminal, it means it's been removed. So let's try the same for the other container. Let's see if we can remove it straight away. And yes, we can. It looks good. So now that we've done that, can we try running the docker rmi commands again? Yeah, we could. We could just run deleted. What's another command? There we go, we found it. So this is the last command we can run to remove the other image, and boom, just like that, the images have been cleared on Docker Desktop 2, showing us that they've definitely, I guess, they're definitely not a part of our local Docker kind of workspace anymore. Okay, that's cool. So that was successful. Last few bits, let us talk about what was one thing we didn't expect in this project. Oh my goodness, what would you say? What would you say is one thing you didn't expect? One thing we didn't expect, for example, was seeing how quick it is to deploy an application using Elastic Beanstalk. That was so much fun. Next, how much time did this project take you? This project took us 2.5 hours, including all the demo time. Whew. Thanks for doing this project. Why did you do this project today? We're super curious. We'd love to hear your feedback. Did this project meet your goals too? Or was it something that you weren't expecting to do at all? You just ended up doing it and you thought, oh, you know what? That was actually pretty fun. Or I actually learned something from this. So let us know your thoughts. Please also just share your personal opinions. I'm going to be writing down something random here, but please pause this video right now and give it your own personal response before we keep going together. Let's say we did this project together as a first go at using containers. Mission accomplished. Well done. I think that is it for all of the questions for this project. So shall we scroll to the very bottom of this page, because what it's going to show us is this beautiful mission accomplished button that will only be activated when this project can tell that you've answered all the questions. So click on that. Boom! Now you can access a wonderful generated PDF with your work. Alright, that generated PDF is still coming, it's still on the way. So in the meantime, let's check out the summary of today's project. Nice work! You just conquered the world of containers and Elastic Beanstalk. You've learned how to install and run Docker. You built a custom Docker image. You also created a new container based on that image. You learned how to resolve port conflicts. And then you also even deployed that image to AWS Elastic Beanstalk, which served your application in the cloud, and that meant anyone could access it using the internet. So that's pretty awesome. That's honestly so decent for a project. So let us check in on our documentation. Thankfully it's created now. That's great. And wonderful. You can see all of your work all come together on this piece of documentation. I'll move it here actually to my main page so you can see it properly. Okay, so your documentation is looking pretty good. Even introduces today's project. It puts together all of the responses you've written for our questions. And look at that, it's also designed in a way where the formatting is very clear. Everything should flow really well with each other, have a relationship with the image that you've screenshotted, and it can really tell a story about your entire project experience. So we hope you enjoy this generated PDF as well. Don't hesitate to share it with the world. There's a button just for it. You can share your work on LinkedIn by using this template. And you know what? All you have to do is highlight or tag next work like this. Make sure to tag us so that we get notified about your posts and we can come and support. I see that there's a bit of a formatting issue here. So what you'll have to do is you have to create a new line like this. And then you can click on that X here to exit this little preview so that you can now add your own documentation like this from your downloads folder. Okay, just like that. You can even give it a name. So creating containers and deploying them using Elastic Beanstalk. Oh, let's be clear. We're deploying our web app with Elastic Beanstalk. So it should be creating containers plus deploy web app. Okay, actually let's just call it create containers. Oh my gosh, that was so wordy for no reason. Create containers plus deploy web app. With Elastic Beanstalk. If I can, I would say create containers with Docker and then deploy web app with Elastic Beanstalk to make it very clear that it's not like we created the containers with Elastic Beanstalk too. That's not really what happened at all. So that's what I would change about the title if I could. And yeah, all you gotta do is click done and then click post and off it goes into the world. Insane. So cool. So all in all, thank you so much for joining me in today's project live demo. That was so much fun. That was so much learning. And there was so much activity in the chat as well, by the way. Everyone having their own definitions of things, helping each other out. A big shout out to DevOps methodology especially. And there's also Praneeth as well, Desiree. There's also Erwin. Oh my goodness, everyone is doing so much cool stuff in the community. And I think it just makes learning an even better experience, and it just makes Nextwork an even better place as well to learn. So thank you so much for being here. Thank you so much for spending your time here. I can't wait to see you again, and in the meantime, please keep well, and we'll stay in touch over the Nextwork community. I hope you know where to find us, by the way. You just gotta find us at community.nextwork.org like this. And you'll be able to find us in all of our free AWS projects right away. Okay, oh, we even have someone saying that there was an issue with attending. So we'll help you out soon to the person that sent this. So I hope to see you there. You can find the free AWS projects from here. You can also straight away just visit nextwork.org to visit all of the projects for free. And I hope you have a lovely time, happy learning, and ask us any questions. Thanks and shout out to Desiree for saying round of applause to you, Natasha, and all of us. I love that part. Thank you, Desiree. All right, see you next time, and thanks again. I hope you enjoy the next project just as much as this one too.